We are now in section 3 of our study guide. This one is all on factoring. So we're going to start it out pretty simple with factoring out a monomial GCF. So really it's just like factor a GCF out. I've taught you how to do this with a box. So we are going to have a 1-2 term here. Let me say that again. That's 1 and 2 terms. So that's a binomial. So we need a 2 box. So 1 by 2. So this time we're going to put it on the inside because we want to break it up into its 2 factors, so it's 2 pieces. So now that it's in this nice organized box, you don't have to use it, but it's there for organization. Let's look at 8 and 2. Do those have any factors in common? Meaning, can they be divided by a number? And you need to pick out the biggest number they can both be divided into. So for this one, it's going to be 2. They can both be divided by 2. Now I've also got 3x's here and 1x here. I'm going to have to take out that 1x because I can't take out more than it has to give. So my GCF here is 2x. Now once we factor out the GCF, we need to make sure we say what's left over. So this is a division step. So 8 divided by 2 is 4. X cubed divided by another x. Remember, we're going to subtract this x up here, so it's x squared left over. Then I've got negative 2 divided by 2, that's negative 1, and my x's cancel. So that's 4x squared minus 1. Now we just need to put it all together back into our 2 factors. So this polynomial is 2x times 4x squared minus 1. And there you go, you factored out your first GCF on this. Let's try this one. It's a 1, 2, 3 terms, so it's a trinomial. So if I want to use the box, I need to use a 1 by 3 box. But we don't have to use the box. We can also just do it by hand. We know the GCF goes outside, and then we've got the parentheses with what's left over after we divide. So if we don't want to use the box, this is the way we need to go. I've got 6, 12, and 3, so I'm going to have to pull out that 3. And then they each have at least an x. So whenever you have multiple variables going on, always go with the lowest amount. So I have to go with just x. Once I pull out that 3x, what's going to be left of my 6x cubes? I'm going to have a 2x squared, so that if I multiply this back together, I would get the 6x cubed. And then I have my 12x squared. I still have 4x. So if I multiply this back together, I would still get that 12x squared. And then finally, of that 3x, I just have a negative 1 left over because it was negative up here, so that if I said 3x times negative 1, I'd get that negative 3x back out. So there we go, that's it without the box. You've got 3x and then parentheses 2x squared plus 4x minus 1. Those are our 2 factors. In my next one, I'm going to go back to the box. I know we like that, so I'm going to keep using that. We've got our 21x squared y squared and our 49x. So I'm thinking 21 and 49, they don't have a lot of factors, so it's going to probably be 7. And let's just double check that real quick. Yeah, I just have a 3 left over here and just have a 7 left over here. So that's not going to have anything bigger to pull out. Then I've got 2 x's here, I've got 1 here. I've got to go with the lowest amount. I've got 2 y's here, none here. I'm going to have to go with the lowest amount, which means none. They do not have y's in common. So once I pull out that 7x, I'm going to divide by it to figure out what's left over. And I get that 3 that we were talking about earlier and x y squared. On this one, my x's cancel, so I'm just left with that 7 that we talked about. It's a positive 7, so that's where my plus came from. So I have 2 pieces of factor here. I've got 7x times 3x y squared plus 7. So if I distributed that 7x out, I would get my original polynomial. My next one here, 22ab plus 121. Let's try to do this one again without the boxes, okay? So I've got 22 and 121. I realize those are both divisible by 11. I've got AB over here, but I don't have any variables on this one, so I can't pull out any A's or B's. So it's just an 11 out there. When I pull that out, I get 2AB. So that was 22 divided by 11, which is the 2. And then 121 divided by the 11, which is another 11. So if I distributed this again, I would get that exact same polynomial out. So there we go, all done. Now let's go ahead and factor trinomials. So I didn't put any GCFs in this one little section here, but that does not mean that you can't have any GCFs. It's just not in this section. That should always be our first check. So let's go ahead and get started. I'm going to put in some ninjas real quick so I can see all my ones. And we have to use our 2 by 2 box to factor this. And then I'm going to pick out what my A is, what my B is, what my C is. My A on this one is 1, my B is -1, and my C is -6. So when I multiply my A and my C back together, I'm getting -6. So that's 1 times -6, which is -6. Now I've got to split that back apart again. I need to find two things that multiply to -6 but are adding to this B that we skipped over. So what's happening here is my first term is in my first box, my last term is in my last box, so this one's here, and it's this middle term right here that we're splitting between these two boxes. I'm going to have some of my x's here, some of them here. And that's what comes back to these numbers right here. If I say -3 times a +2, then it multiplies to -6 but adds to -1. So those are the numbers I want to go with. I can put them in any order I want, but I think it would be neat to put my negative with my other negative and make it a little easier that way. Now I'm going to pull out my GCF to the side. So when I have all these x's here, I'm looking at them, 2 here, 1 there, I can pull out the 1. Always go with the lowest amount again. Once I pull out that x, what's left over goes along the top. So for my x squared, I still have an x left over. For my 2x, I just have that 2 left over. So that's after I pulled out the x. On that bottom row, whenever your first term's negative, we're going to automatically pull out a negative. However, this one we are going to pull out all of the -3. It doesn't have to be that number every single time. In this case, it just happens to be that one. So when I pull that out, here's my check down here. Do I get x and 2 again? Yes, I do. So I know I pulled out the right number right here, and I know I used the right factors right here. So my two factors are x minus 3 and x plus 2. If you switch the order of those around, that's okay. You could have put that one first and that one second. Multiplication, it doesn't matter what order we do it in. Now I look at 23. I've got 5, 7, and 6, just checking for that GCF, and I know those don't have any factors in common. So I'm going to go straight for my A, my B, and my C, because I'm going to go fill this into this box. My first term and my last term are fine. And I need to split up that middle term right here using my A, B, and C. So A is 5, B is 7, and C is -6. So when I multiply A and C together, I'm getting -30. And now I need to figure out some numbers that are going to add to the 7 right here. And I'm thinking through them, and I'm thinking 10 and 3, as long as my 3 is negative. And that's going to work out perfectly, because it's going to multiply to a negative but add to the positive. So I'm going to put those in whatever order. I think it makes sense to put my 10 with my 5 and my -3 with my 6. Now it's really easy to pull out my GCF. I've got 5x on my top there, which is an x and a 2 left over. So that 5x times x was that 5x squared, and 5x times 2 was the 10x. Now on the bottom there, first term's negative, and I get to pull out all of that -3 again. And then I get x and +2 again. So I get 5x minus 3 and x plus 2. So these are my factors to this polynomial. Now let's move on and do another one. I've got a couple more on this page. I've got number 22 here. And I see my A is 2, my B is 9, and my C is another 9. So let me get my 2 by 2 box ready to go here. I've got the 2x squared and the 9, and I just need to split up that middle 9x there. So when I multiply my A and my C together, I get 18. That was my 2 times my 9. And then I need to split that apart again. I'm thinking 6 and 3. 6 times 3 is 18. 6 plus 3 is 9. So I think it would be best to put my 3 with my 9 and my 6 with my 2 up there, so that when I pull out the GCF, I can actually pull out a 2x on top and an x and a 3 left over. Now on the bottom row, I have 3 pulling it out. That's what they have in common. And then I have an x and a 3 left over. That's my check, so it worked out. So I get two factors, 2x plus 3, that's along my side, and then I've got x plus 3. In case you missed it, yes, you may change the order of those, doesn't matter. And if you put these in a different order as well, you're just going to get the same numbers just on different sides. So order here doesn't really affect it at all. So now let's look at number 24, excuse me, I'm going to the wrong number. I've got a new A, which is 3, a B, which is -2, and a C, which is -8. Running out of room here, so I'll be careful. My first term and my last term are in the right positions. So let me figure out what I need to split this negative 2x into. So my a times my c is negative 24 in this one. And I'm thinking probably something close together like 6 and 4. And as long as my 6 is negative, so that when I add them together, I still have a negative number left over. So I'm going to put those in whatever order. I think my 4 would be awesome with my 8 up there, and my 6 would be great with my 3. Just make sure you don't lose that negative. Now I'm going to pull this out. I've got my 3x to the side, my GCF of that first row, and I have an x and a negative 2 left over. Then I've got a 4 on my bottom row that I can pull out, which gives me an x and a negative 2. That's awesome. Notice on that bottom one, I didn't have to bring out the negative because my first term wasn't negative. That's the only time you have to do that. So my check worked out, and I've got my 3x plus my 4, and my x minus my 2. Now I'm really out of room here, but that's okay because these are not trinomials. I'm not going to use my 4 box anymore. These are binomials, so they have 2 terms. Notice their subtraction. There's very few things we can do to binomials. We can take out GCFs, or we can do a difference of squares. So these factors always look the exact same way. So you need to see a variable squared, and you need any of your numbers to be perfect squares. So in this case, 8 squared is 64, so 64 is a perfect square. So it's going to be plus and minus, the exact same thing. So x times x gives me x squared. 8 times 8 gives me 64. And that's all you have to do for that. Those are the factors, so that's a pattern you have to have memorized. We've got another binomial here, so let's check to see if it's a difference of squares. It is subtraction like we need. It's a perfect square right there, that's 4 squared, and 81 is 9 squared. So y squared is also what we need. We need all of our variables squared. So I know what they're going to look like. It's going to be plus and minus, the exact same thing. 4y times 4y would give me 16y squared. 9 times 9 would give me 81. And there you go, all factored. We have another part to this, getting this moving along here, getting a little harder each time. This is actually the same skill. We're just kind of putting everything together from the last page. So we're going to factor out a GCF of each polynomial, then factor completely. These are key words right there. That's why they're underlined. A lot of times they'll put that there so that you know there's a GCF. So if you see factored completely, go ahead and expect there to be a GCF to pull out ahead of time. So we're going to pull that out first. So when I look at 3x squared minus 27, I notice that 3 and 27, those are both divisible by 3, so I can pull that out. When I pull that out, I get x squared minus 9. Now we're not done because any time that we pull out a GCF, we should check to see if that's factorable as well. And yes, look at that. We've got a variable squared, we've got a subtraction, and 9 is 3 squared, so that's a perfect square. So yes, we can change this using the difference of squares we were just talking about. X times x is x squared, plus and minus. 3 times 3 would be 9. And now it's done. So this would be your final answer. Don't lose your GCF. Now notice on that one, I did not use my box to pull out the GCF. That was because it was a very short one. I didn't think I would need it. But if you would like to use your box, go ahead and use it. So let me use the box on number 29. So 5, 30, and 45, I can see there's a GCF there of 5. So I'm going to pull that out using my box this time. If you don't want to use the box, please don't. You can skip the step. So I saw that there was a GCF of 5 there. And that means I'm going to divide by that 5 to get a simpler polynomial. So I'm getting x squared out. I'm getting a negative 6x. And I'm getting a 9. So that's a positive 9. Now that top polynomial, that simpler one, is the one I'm going to factor now. So it's like a simplified fraction. You want to always use the simplest form that you can. So I'm going to pick out my new a, b, and c, but do not lose that GCF. Remember, the F stands for factor. That is part of your factor. You can't lose it. So I'm going to go to the 4 box because that new polynomial is a trinomial, and my first and my last term are fine. It's that middle term that we need to split up. So my a, b, and c, I'm running out of room here, so I'll try to fit it all in. My A is 1, my B is -6, and my C is 9. When I multiply my A and my C together, I get positive 9. But this has to add to a -6. So what I know is this is going to be a negative times a negative, because that's the only way to multiply to a positive, yet add to a negative. So I'm going to go ahead and pick -3 and -3. So in any order, you want to put those. And now let me factor out sideways. I get an x and then an x and a -3 left over. I can pull out that -3, which gives me an x and a -3. So my check worked out. So I could write this twice, x minus 3, x minus 3. Or I could write x minus 3 squared. Now don't forget that you have this GCF right here, so put that on the outside of your parentheses. You have not found every single factor until you put that GCF there. When we're looking at the SOL later, it's going to be one of those multiple click questions. And you're going to have to make sure you click 5, and you're going to have to make sure you click the factors as well, x minus 3 and x minus 3. Let's do a new one, 8, 8, and 42. At first I was hoping that 8 would be our GCF, but 42, 8 doesn't go into that. So we're going to have to pick something smaller, maybe 4, but that doesn't go into 42 either. So we're going to have to go as small as 2 on that one. So I have a GCF here of 2. You can use the box if you want. You don't have to. Let me switch out to a sharper pencil here. Sorry. So I have 8x squared, 8x, and -42. And I said I could pull a 2 out of all of those. They were even, so at least I knew that. When I do that, then I get 4x squared left over, plus a 4x, minus a 21. Now remember, that is part of your answer, so don't lose that GCF. But now we've got to go and factor this trinomial. So remember, trinomials, you always factor with your 2 by 2 box. So our first term and our last term of our new simplified polynomial are fine. We just need to make sure that we split up that middle 4x. So let me go ahead and write down my A, B, and C. And I get that A is 4, B is also 4, and C is -21. So my A times my C is a bigger number than usual. It's -84. And I'm going to go ahead and split that up and try to find something that adds to this 4 right here. Now I don't want to miss any terms, so I'm going to start at 1. 1 and 84. It's needing to add to a positive, so I always know it's my smaller number that's going to be negative in this case. That's nowhere close, so let's try our next one. -2 and 42. Still not close, so let's keep moving. Let's try 3, -3, and let's see how many times does that go on. 28 times. Still not close enough. Let's move on to 4. So -4, and it goes in 21 times. Oh, I should have known that. It's from our factors there. Still not close enough to add to our 4. So let's keep moving. 5 can't go into 84, so I'm going to skip to 6. -6 times goes into there once, and then got 24, so 14 left over. So -6 and 14. That's getting pretty close. That's at 8, but we need it to go to 4. So let me keep trying my next one. 7 doesn't go in, so let's, well, does it? Yes, it does. Shouldn't skip anything without trying it. Goes in 1 time, and then 2, so 12. Oh, we're so close now. We're at 5, but that's still not good enough. My next number is going to be 8. 8 can't go into 84 because it goes into 88. So 9 goes into 81, can't go into 84. So let's think 10 doesn't go in, 11 doesn't go in, and we're back to 12. We've already used 12, so we've completed the circle. So we know we've tried every single number. Once you've tried every single number, you can actually stop. This trinomial right here is called prime. But you did factor it a little bit, so you can't just say overall this is prime. It's 2 4x squared plus 4x minus 21. So the most you could do is pull out that GCF, but that is considered factoring, so we did factor a little bit. We just couldn't take this further because that one was prime. Now let's look at number 30. 3, 3, and 90. Oh, definitely pulling out a 3 on this one. So when I'm going to try to do this one in my head. When I pull out that 3, I have an x squared, and just an x, and a negative 30 left over. That one was a pretty easy one to do in your head. So that was a good start to try to do them there. Now, I have a trinomial, and I need to try all my factors. But before I do that, I'm going to put in my Ninja 1 in the middle there. A lot of times we forget what number's in the middle when we cancel it out like that. So I've got a 1, and a negative 30. So when I go to my 4 box here, I've got my x squared and my negative 30. So I'm factoring this polynomial. And my a times c is my negative 30. So I need something times something that multiplies to negative 30, but is adding to this b again, so that I can split up that x in the middle. So I'm thinking something really close together like 6 and 5, as long as my 5 is the negative 1. I'm going to put my negative with my other negative, because I think that will be nice and simple. I'm going to put my 6 up here. So when I factor this out sideways, I'm going to pull out the GCF. I've got an x that I can pull out, and I have an x and a 6 left over. Then in the bottom, remember whenever that first term's negative, you can pull out that negative, and it's all of negative 5. That means I have an x and a 6 left over again. That's my check, and it worked out. So this has 3 factors. Make sure you find them all. You've got your GCF that we don't want to lose, so that's 3. And then we have our side and our top here. So x minus 5 and x plus 6. And there you go, all factored completely. Now for this next section, I have put everything here. I haven't told you what you need to do. So this is a lot like the test. You kind of have to figure out exactly what to do on your own. So we're going to start on 31 and kind of think through the thought process here. The first thing we should always do is try to pull out a GCF. So I see 12 and 27. You know what? Those have a factor of 3 in common. So let me go ahead and pull out that 3. That means I have 4p squared minus 9. Now what's left over is a binomial. The only binomials we can factor are the difference of squares. So is 4 a perfect square and 9 a perfect square? Yes, they both are. 4 is 2 squared and 9 is 3 squared. So this means that our 3 is fine, and then we're going to get 2 new factors. It's the plus and minus of the exact same thing again. 2p times 2p is the 4p squared. 3 times 3 is the 9. So there's our difference of squares done again. For 33, I'm going to go ahead and try to pull out that GCF again. 6, 9, and 3. Yeah, you know what? I can pull out a 3 there. If you'd like to use your boxes, that would be a 1, 2, 3 box. You can use it, or you can try to do these more and more in your head to save yourself some time and energy. So I'm pulling out that 3, which means I have a 2n squared left, a negative 3n left, and a negative 1. Now I need to go and factor, if I can, this trinomial. That means I need to pick out my a, my b, and my c. My a is 2, my b is negative 3, and my c is negative 1. So when I multiply my a and my c together, I get negative 2. Now our only factors of 2 are 1 and 2. And it needs to add to a negative, so my bigger one needs to be a negative. Now this is a case where we're seeing another one that we would call prime, meaning we can't factor this any further. Because 1 times negative 2 might multiply to negative 2, but it's not adding to the correct b. So this is done, and this is the answer we would put when it asks for factored. Because we did pull out a factor, we just weren't able to factor this trinomial anymore. So it's not technically prime. We have a little bit we can do. Now let's look at our one right here. We've got number 32, we've got 21, we've got 49, and we've got 35. I can tell that we can pull out a 7 there. But do you notice it seems like our S's, we have a lot of those, so maybe we can pull out some S's as well. I've got 4 here, 3 there, 2 there. So they have that 2 in common, so S squared. Whenever you're trying to pull out the variables, always go with the lowest amount available. So I've got 7s squared, and then I can have what left over. So I'm trying to do this more and more in our heads as we go along. So we've got our 3s squared plus 7s minus 5. To help you out, if you're having a little bit of trouble doing this in your head, I'm taking each of these terms and I'm dividing by that GCF. So 21 divided by 7 is the 3, 49 divided by 7 is the 7, and negative 35 divided by 7 is the negative 5. And then I'm canceling out the s's because I pulled them out into front. Now we need to keep trying to factor this trinomial. So I want my a, my b, and my c. So my a is 3, my b is 7, and my c is negative 5. So I'm getting those numbers from my coefficients from my trinomial. So I'm going to multiply my a and my c together. That's negative 15. That was 3 times negative 5. And I need two things to multiply to the 7 right here. And I think I said that backwards. I need two things to multiply to the negative 15, but add to the 7 right here. So let me think of all my factors of 15. Negative 15. I've got negative 1 and 15. And I've got negative 3 and 5. And then I'm done. Now, none of those factors that we just pointed out actually add to my 7 right here. So again, we're stuck after the GCF. I can't go further. All right, final example, number 34, and we'll be done. You've got a 3, a negative 29, and a 10. 29's prime and 3's prime. So I can already tell that this is not going to have a GCF. Those are just too many primes right there. So the only thing I can do is jump to my A, my B, and my C. I'm going to try to factor the trinomial in our 2 by 2 box. So I've got my first term, my last term, and I'm going to split that middle term up. So my A is 3, my B is negative 29, and my C is negative 10. So my A times my C is negative 30. And now we've got to find something that is multiplying to negative 30, but adding to negative 29. I think it's a pretty simple one because we didn't have to think too hard on that. That was negative 30 and 1. So I'm going to put my negative 30v with my negative 10. I'm going to put my 1v up on top there. So when I pull out my GCF sideways, I can just pull out a v. And I'm left with a 3v and a 1 left over. To the side here, I need to pull out a negative. And it needs to be a negative 10. That's my GCF of the bottom row. And then I get 3v and 1 left over again. So my check worked out. So I just have the two factors in this case, no GCF. I've got my v minus 10 and my 3v plus 1. There you go. Now, as you get better and better at factoring, I do expect you to skip more and more steps. It's okay not to show every single step as long as you're getting them right. But if you're not getting them right, keep showing all the work until you are. All right? All right, good luck on your test.